Welcome to A-Star Science, part of our GCSE Must Know Chemistry series. Today we're going to be talking about the families of organic molecules called alcohols and carboxylic acids, and talking about some of their properties and their reactions. First, let's remind ourselves that alcohols have this functional group, which is a C to an O to an H, C meaning carbon, of course, and that could be attached to any other chain, long chain carbon. So we call those alcohols, specifically when they have that OH functional group next to it, next to the carbon. Then we have the carboxylic acids. And they have a carbonyl group, which is C, a carbon, to a double bond to an oxygen attached to an OH group. And we call those carboxylic acids. And of course, they're named the same way that the other organic molecules are named. So for example, if it had one carbon, we would call it methanol for the alcohol. And if it had one carbon for the carboxylic acid, we'd call it methanoic acid. One carbon, we use meth. Same thing will be two carbons, will be ethanol, or two carbons for the carboxylic acid, it will be ethanoic acid. So the naming is the same. So let's start talking about the alcohols first and the reactions of alcohols. Now we should know that alcohols actually are weak acids. And that's because of that H plus that is at the end. So alcohols are weak acids, but they can also act as weak bases. You don't really need to know this for GCSE, but for those of you who are going to move on to A-level chemistry, you need to be aware of this particular property. Second property is that alcohols are soluble in water. Soluble means to dissolve. So they're soluble in water. However, as the chain length increases, the solubility decreases. And this is because of the other carbons and hydrogens that will be on the chain. They start to change the properties of the charges around the molecule. You do not need to know the reason why for GCSE, but you do need to know that as the chain length increases, the solubility decreases. So something like methanol, which is a short chain, one carbon, like that would be methanol. Its solubility would be greater than, for example, butanol, which would have 4 carbons, like that. And the rest would be H's around it, like that, and then an OH. So that butanol would have a lower solubility than methanol. Okay, so that's another property that you need to be aware about. Now, the third property that we use alcohol for a lot is they're very flammable, meaning they undergo combustion, and it is quite clean combustion. So we call this complete combustion. So an alcohol, when it combusts with oxygen, you're going to get carbon dioxide plus water, depending on, of course, on what the alcohol is. But you're going to get those two products. And we know it's complete combustion because of the carbon dioxide rather than carbon monoxide. And so this is an important reaction because alcohols can be used as fuels. So let's continue. Now, alcohols, as they are weak acids, can also react similar to water with metals, especially the reactive metals. So, for example, alcohols plus sodium will give an alcohol salt, which has a special name for it, plus hydrogen gas. Okay, so for example, if I took ethanol, so here's ethanol. We call it ethanol because it has 2 carbons on it, plus sodium. We're going to get an ethoxide, which is an alcohol salt. Just put the hydrogens in, plus hydrogen gas. Okay. I'm going to let's create a bit more space so we can look at that more in detail. Let's do that one again. So we have the alcohol plus a reactive metal. The metals that are somewhat reactive, like magnesium, will not give much of a reaction. You're going to get an alcohol salt plus hydrogen gas. So for example, if we took ethanol, two carbons, the rest are hydrogens, like that. And we added the metal, for example, sodium. You're going to then see this alcohol act as an acid. And that means it's going to donate an H plus. And so that's going to dissociate. And the sodium, which acts as a plus ion, is going to bond ionically to the ethoxide molecule. The hydrogen will come off and you're going to get hydrogen gas forming like that. So this is an important reaction that you need to remember for A level as well. Let's continue talking about the reactions of alcohol. I think we're on E. So alcohols can also react with oxidizing agents, which we just write as this symbol and an oxygen in some square brackets. And this can form carboxylic acids. Plus water. Now, this is a reaction that you need to know for GCSE, but you also need to know it for A level as well. For A level, you will have to understand what the particular oxidizing agents that you can use, as well as the conditions that you need to use it under. But for GCSE, you just need to know that alcohols plus an oxidizing agent can form carboxylic acids plus water. Remember that the carboxylic acid that you form is going to be named after the alcohol that you use. So if I use ethanol, I'm going to form ethanoic acid plus water. Another reaction that's important is you can actually react alcohols with carboxylic acids to form esters plus water. This is called esterification, okay, and it's a type of condensation reaction. So this is important, and I actually have a separate video on this. So if I take, for example, methanol plus ethanoic acid, I'm going to get methyl ethanoate. That's the name of the carboxylic acid, which is, sorry, of the ester, which is always named after the carboxylic acid side. So ethanoic acid becomes ethanoate, methyl ethanoate, plus, of course, water. Please go back and look at my video on how condensation reactions are carried out so you can fully understand that. So those are the reactions of alcohols that you need to be familiar of. Of course, alcohols are really important, as we said. They're important feedstocks for other chemical reactions. They can be used as fuels. We use them in medicine, a really important organic molecule. Let's take a look now at carboxylic acids, which we've mentioned at the beginning of the video. So now let's look at the reactions of carboxylic acids. The first thing we want to remember is that they are weak acids. And so they have all the properties that acids tend to have. That means that they're going to have, for example, a low pH, or below 7, we should say. So that's below 7 on the pH scale. Okay. Number 2, as a weak acid, a carboxylic acid is going to react with carbonates, with metal carbonates. And they're going to form a salt plus water plus carbon dioxide gas. And so we can look at an example of that. For example, if we take ethanoic acid, ethanoic because it has 2 carbons, plus let's take sodium carbonate. So these two are going to react together, as we said, to form the salt. So you're going to get an O minus and an Na plus. Plus the hydrogen that's donated becomes water, H2O. Plus then we're going to get carbon dioxide liberated from that. We can balance that, of course. I think there's a 2 here, and then there's a 2 here. That should give us enough across the board. But you need to just know that carboxylic acids plus metal carbonates are going to give a salt plus water plus carbon dioxide. The salt will depend on how many carbons that you have. What's the particular carboxylic acid that you're using? Let's look at the next reaction. We can get carboxylic acids. Again, just like we said, they're weak acids. And they can react with metals, especially the reactive metals, such as sodium and magnesium. And that's going to give a salt, because acids plus metals give a salt plus hydrogen gas. Okay, so for example, again, if we take ethanoic acid, common name vinegar, and we react it with sodium, you're going to get that carboxylic salt. The H plus has been donated, So now the sodium bonds on to the carboxylic, to the carboxylate salt, carboxylate ion, as well as we're going to get the hydrogen gas forming. We can put a 2 here, 2 here, and a 2 there. I think that should balance it out. But nevertheless, the carboxylic acids plus metals give salt plus hydrogen. Another important reaction that you need to remember. So reaction number 4 is we need to know that carboxylic acids they can also dissolve in water, and that just forms an acidic solution because they're already acids. So when you put them in water, they form an acidic solution. So I will demonstrate that. I'm going to use ethanoic acid again. And when we we dissolve it in water, we're going to get the formation of the carboxylic ion, carboxylate ion, plus H3O plus, which is where the water has picked up an extra hydrogen. That extra hydrogen has come from this H plus, which is donated. And so now it's basically this carboxylate ion here dissolved in water. These two are basically the same thing. These H3O or hydronium ion plus the H plus ion are basically the same thing. So the carboxylic acid can dissolve in water to form an acidic solution. And finally, as we spoke about earlier, carboxylic acids, I'm going to do 2 more actually, can react with bases because they are acids, and we know that acids plus base yields salt plus water. So for example, if they reacted with sodium hydroxide, you're going to get a salt plus water. Now this is an important reaction because you can form buffer solutions, which you're going to learn about in A-level chemistry, from these types of reactions. The final reaction we spoke about earlier was that you can take carboxylic acids and react them with with alcohols, and that's going to form esters, an ester plus water, and we call this a condensation reaction. Now esters are important because we can make polymers from esters, biodegradable polymers. So this is an important reaction as well. So please like and subscribe, leave a comment, and let me know if there's any videos that you would like me to do so that you can master your GCSE science. That could be chemistry, physics, or biology.